My name is John. This is Keola. Over there is Mitch. We are presenting the electronic portion of our hydro-powered renewable energy device. On the proto board here, we have our microcontroller and our boost converter circuit. The microcontroller is powered by a battery. We have a voltmeter on the output to show that we are getting appropriate output voltage. Our device accepts input voltages as low as 2 volts. Let's see, go down further, adjust this. Yep, as low as 2 volts, it can still get up to within half a volt of 5 with standard 5, and we can just go up to about 4 and show that it still manages to stay stable. You see our output there, and our output signal has no ripple. It has a bit of transient from the switching and the discharging of the L and C components. The device is capable of charging anything with a USB connection. As you can see, we have a little portable battery here. You can see the orange indicator light down there. And we can switch to our cell phone like this, and it will begin charging. Like so.
And I'll be discussing the differences between a multi-sim simulation as well as our real-world values. So, looking at the simulation, we have a 120 microhenry inductor and a 4.7 millifarad capacitor, which gives us the output that we want, just under 5 volts, which is totally within the range, the margin that we have set in the past, with a ripple under 100 millivolts. So this is very ideal. However, these two values that you see are not what we used. So, to start off, this capacitor value was not available to us. So the biggest one that we had at hand was 2.2 millifarads, which also gives us a different ESR. And so we did additional calculations for the inductor and got one about half the value of this, about 68 microhenries, which also gives us a different ESR. So the combinations of all these effects was able to give us the output that we want. So if we compare the simulations between this and what we actually have in the lab right now, then we'll see not much of a difference. Spoiler alert. It goes right back up to where it was before. So, what was I going to say? I don't remember.
All that to say, that just means that our actual calculations and realistic adaptations to the simulation ended up yielding precise results.
See the other road now? See, look, it works when we don't have a road. Yes, sorry.
Okay, so after using our intended generator that would be within the final product, we noticed that our system attempts to adjust and does an okay job at adjusting, although it doesn't stay within the ranges that we intended it to. These are things that we learned that we have to deal with, and after going back into the code for like a second iteration, we know that we could easily solve this problem. Either way though, as you've just seen in the video, the phone and the battery charger still charges, so that's a good thing. So for a second part in this project, we would probably fix those things and add some extra design things. Yeah, implement extra design features.